The second method that we want to look into for this standard is looking at something called traversability. So the word traverse means travelling, and so this is all about travelling and moving around. So a little reminder first of all about the order. So when we talk about order, we can talk about odd vertices and even vertices. An odd vertice that has order 1, that just means there's one arc that goes into that node. If you've got the number 3 is another odd number, so order 3 would be a node that has 3 arcs going into it. Equally, order 5 means it's a node with 5 arcs going in. Even vertices or even nodes would be numbers 2, so that means you've got 2 arcs going into it, 4 arcs, 6 arcs. Okay, so just a reminder about those ideas of what the order is and what odd and even vertices or nodes are. So this problem originally came from something called the 7 bridges of Koinsberg, and this was a problem that a mathematician in Russia came across in real life and worked out could he solve it, and came up with a method for that. So there are 7 bridges in this town of Koinsberg, and he wanted to know if it was possible to cross every bridge once and only once. So here's the diagram of the actual city, and you can see that there's this river that goes in and around, and that the green blobs in the middle there, those are the different bridges. So from one side here, from the bottom to the middle island, there's a bridge, and further down there's another bridge from the bottom island to the middle island. There's bridges going from the island to the top piece, island to the top piece, then there's a top piece to the side, island to the side, and the side to the bottom. So if we take those ideas of bridges and make the bridges our arcs, then the nodes are the places. So the island is a node, it's one place. This piece down the bottom here is another node, and so on. And I end up with a diagram that looks like this. There are 4 areas. There's the top area, there's the island, there's the bottom area, and there's a side to the east. And these arcs here are all the bridges that we could cross. And so the problem is, could we cross each bridge once and only once? So we need to do this traversability test. So we've got to look at whether they are odd nodes or even nodes. So that's our first thing we do, is work out what's the order, and are they odd or even. Then we look and say, right, if you've got no odd nodes at all, so all of your nodes are even, then that means your network is traversable, and you can start and finish at the same place. So you start somewhere, cross bridges, and end up back where you began, and you would have crossed each bridge once and only once. If there are 2 odd nodes, okay, so that means you've got all your nodes ordered and there's only 2 of them that are odd, then your network is still traversable. But it means that you'll need to start. You can't start and finish at the same place. It means you'll start at one place, cross over some bridges, and you'll end up at a different end point. So you're going to start at one of the odd nodes, and you're going to finish at the second odd node. If you have anything else, so if you don't have 0 or 2 odd nodes, then your network is not going to be traversable. So if you had 1 odd node, it's not traversable. If you have 3, 4, 5, 6, 7, 8, 9, 10, any other number other than 0 or 2, then your network is not going to be traversable. So let's start and apply that test to this one. So we need to find the order, and I'm going to start with node A. So we've coloured that one in red to say that's where we're starting, and I'm looking at how many arcs go into node A. So I've got 1, 2, 3, 4, 5. There are 5 arcs that go into node A, so that means its order is 5. Now 5 is an odd number, so that means A is an odd node. Now let's do the same process again and look at node B. So I've coloured in node B, and if I look at how many arcs go into node B, I've got 1, 2, 3. There's 3 arcs that go into node B, so that means its order is 3, and 3 is an odd number, so B must be an odd node. Now let's try node C. C has got 1, 2, 3 arcs that go into it, so that means its order is also 3. 3 is an odd number, so there it is an odd node. Last but not least, we need to do node D down the bottom, and node D has got 1, 2, 3 different arcs that go into it, so that means its order is 3. 3 is an odd number, so it is an odd node. So this is what I end up with. I've got each of my nodes now has an order and whether they're odd or even written next to it. Now I need to count up how many odd nodes there are. So I've got node A is an odd node, node B is an odd node, node C is an odd node, and node D is an odd node. So I've got all 4 of my nodes are odd. So that's what my answer is going to be related to, is how many odd nodes. So in this case I said I've got 4 odd nodes. Now if I just go back to the previous diagram explanation, here we go. It says if there are 0 odd nodes, the network is traversable. If there are 2 odd nodes, it is traversable. If there are any other number of nodes, odd nodes, then the network is not traversable. I've got 4. I don't have 0 and I don't have 2. I've got 4. So that tells me my network is not traversable. Just zoom past this. Okay. So there is my answer, that there are 4 odd nodes, and that means my network is not traversable because it's only traversable if there are 0 or 2 odd nodes. So in terms of my working, I need to see that order and odd and even written next to the nodes, and I need to see a written answer here by saying that there are 4 odd nodes, and that means for this Koinsberg bridges, it's not possible for somebody to walk across every single bridge once and only once. Okay, that's what it means, is that there is no way that a person could try and cross over those bridges in just one time. So now what you need to do is go to page 25, exercise E, and I want you to answer the questions there. Now if you're aiming for a marital excellence, you've got 1 lesson to complete this. You need to get these exercises completed very quickly. If you're not aiming for a marital excellence, then you can complete this in 2 lessons, but no more than 2 lessons. So a quick little bit of more information for students aiming for excellence. What do I do to make the network traversable if it isn't? So that problem we just did with the 7 bridges of Koinsberg, it's not traversable. How could I make it traversable? So if the network was not connected, so if for example there was an island that nobody could get to, then we would need to add a bridge to that. We need to add in a new bridge to connect that island together. If the network is connected, then we still need to either add new arcs or take away arcs, and we want to make the nodes into even degrees. Okay, now what does that mean? Let me just go back to the diagram here. So if I've got this diagram here, my Koinsberg, to make this problem traversable, remember, actually I don't want that diagram, I want the final one here, thank you. Let me do that one. This is order 5, order 3, order 3, order 3. I need to have, if I had just 2 nodes that were odd, that would be okay. I can't have 4. 2 would be fine though, 2 would be traversable. So what I could do, if for example from node C to node D, I could add another arc in here. So I could add another arc going from node C to node D. And if I add that arc in there, then that would mean that node C would then be of order 4, which is an even number. Adding another arc to D would make that into order 4, which is an even number. So then nodes C and D would be even, and I've only got 2 odd nodes, and in that case the network would be traversable. We could start at node A, walk over every bridge once and only once, and we'd end up at node B. Okay, so that's one way we could do it. A second way is I could take out an arc. So for example, this arc here between node A and B. Okay, I could take away that node. So if I take away one of those arcs there, then instead of A having 5 arcs coming out of it, it would change to order 4, which is an even number. Node B, if I take away that arc there, would then have only 2 arcs going into it, so it would be ordered 2, which is an even number. So then I've got 2 remaining nodes that are odd, but because I've got 2, that means the network would then be traversable. So I could add or take away an arc to make this network traversable. Okay. Another way just to think about this is it possible to move from room to room using every door once? Okay, think about in your house. Could you walk through every room in your house only going through the doorways once? Now, if you've got a room which has got a doorway going in and a doorway going out, then you could. But if you have a doorway like my bedroom only has one door going out, and in that case it's not possible. I would have to enter in the room and leave the room through that same door. It's only one path to get into that room. Okay, so that's just another way to think about it.